Okay, so this is notes 1.3, communicating with graphs. A graph is a visual display of information and data. The horizontal axis or the x-axis measured time. The x-axis is the independent variable. And I told you variables would make more sense when we got here to this section. All right. Um, Independent variables always go on the bottom. In this case, time is always an independent variable. Okay. On this side, as you're going to see on the next slide, the up and down or the vertical, or the vertical axis is always the dependent variable. Okay. Distance is the dependent variable and is measured on the vertical axis or the y-axis. Y-axis right here. Let me get a highlighter out so we can see this a little bit, or the pointer. Let's try the pointer. Okay. So here's our distance. Okay. This is going to be our dependent variable. Time is independent. Okay. And again, let me go back to the previous slide. A graph is a visual display of information or data. The horizontal axis measures time in this case. The horizontal axis, the x axis, is always the independent variable. And the y axis is always the dependent variable. Why? Because independent variables were not usually in control of time. You're not in control of time. Time continues on, it never stops. Okay. This is independent. Dependent, um, the way the dependent variable changes, it changes by the independent variable. And I know that sounds ridiculous, but in this case right here, how far can that girl walk her dog in this graph? How far can she walk her dog? The distance is how far. It depends on how much time we give her. The more time she has, the farther she can walk her dog. Okay. So the dependent variable depends on the independent variable. Different kinds of graphs, line, bar, and circle, are appropriate for displaying different types of information. Graphs make it easier to understand complex patterns by displaying data in a visual manner. Scientists often graph their data to detect patterns that would not have been evident in a table. The conclusion drawn from graphs must be based on an accurate information and reasonable scales. Line graphs. The three types of graphs we'll talk about: line, bar, and circle graphs. So, a line graph can show how any relationship where the dependent variable changes due to the change in the independent variable. Again, right here, how far can she walk her dog? It depends on how much time she gets or she has to walk the dog. You can show more than one event on the same graph as long as the relationships between the variables um, is identical. Okay, so this is what makes um, graphs so much nicer than tables. Here's my table, okay, room temperatures, and we're looking at a room temperature here. Um, and this table can be a little bit confusing, okay? Room temperature, let's just say all classrooms started at 16 degrees Celsius. You can see it right here. They all started at 16 degrees Celsius, okay? And after 5 minutes, these were the temperatures in the rooms: 17, 17, 16.5. After 10 minutes, you can see the temperatures. But again, and we could go down this list, but if you look at this, the graph is so much easier to see. After 15 minutes, um, or it's so much easier to read. After 15 minutes, this was 16 and a half degrees Celsius. Here's one at 20 degrees Celsius, and here's one at 21 degrees Celsius. After 20 minutes, you can just glance real quick instead of um, reading through the table. A lot easier to read a graph than it is that data table. Okay, the most important factor in making the line graph is always using the x-axis for the independent variable, and the y-axis always is used for the dependent variable. So if we go back again, and I know I keep going back, it's probably driving some of you nuts, but look, time again is on the bottom. You're not in control of time. Time continues and continues and continues. Um, how hot would room B get? What would the temperature be? Well, it depends. If I keep letting time go, that temperature continues to go up. Okay, so um, independent always down here on the horizontal or the x-axis, and the dependent always on the y-axis, always on y. Again, here's a bar graph now. A bar graph is useful for comparing information collected by counting. Here's if we look at this, one classroom has 20 students, three classroom, 21 students, three classrooms, 22 students. And again, if we look at the graph, uh, it just makes that table easier. You can see um, how many classroom with 20 students? One. 21 students, um, three. 22 students, three. How many have 23? Two classrooms, and on and on. Again, the most important thing right here, independent variables, dependent variables. Okay, independent variables and the dependent. Circle graphs. A circle graph or pie graph is used to show how some fixed quantity is broken down into smaller parts. This figure illustrates how a circle graph could be used to show the percentage of buildings in a neighborhood using each of a variety of heating fuels. So here's different type of heating fuels. Okay, 50% of the people or the businesses in, let's just say, Butler, 50% of them have gas, 25% steam. Our school is steam. By the way, we have boilers that boils that water and sends steam to the classroom to heat those classrooms up. Some businesses will use electricity. Some use coal. I don't know of anybody that uses coal anymore, but hey, it's on there. And your other, especially down around where we're at, other could be wood. We're using wood to heat our buildings. Okay. So again, when you're talking about a whole and you're breaking it down into parts, we'd like to use a circle graph. Questions. A graph is a blank of information or data. It is a visual display. Visual display. And which type of graph would be the best choice for representing a child's growth over time? Probably a line graph here. You could use a bar graph, but I think a line graph would look a little bit better. And that's it for notes for Chapter 1, Section 3. Have a great day.